So we're going to look at the number of electrons that change hands when an ionic bond forms. I'll start out with a really simple one, NaCl, sodium chloride. So sodium is in group 1, chloride is in group 17. There's one of each. There's no subscript written, which means we have a 1-to-1 ratio. And since chlorine, which is actually now chloride, has a tendency to just gain one electron and therefore have a -1 charge. That means that one single electron must have been transferred away from the sodium, so it now has a +1 charge, and to the chloride. So if we were asked the question how many electrons were transferred, how many total electrons were transferred, we would simply say 1, right? So it's +1, -1, and they're present in a 1-to-1 ratio. The next step is then to look at a situation where they're not in a 1-to-1 ratio. So let's take a look at aluminum chloride. We'll just stick with chloride as our ion, AlCl3. So the fact that we have 3 chlorides, and once again, we know that each chloride has a -1 charge, means that 3 electrons were transferred to the chlorides, to those 3 chlorides. So 1 electron per chloride times 3 chlorides means 3 electrons had to be transferred over to chlorine to make those 3 chlorides. That means that aluminum now has a +3 charge because we only have 1 aluminum, so therefore it must have supplied all 3 electrons to those 3 chloride ions. So we just used the number of electrons transferred to come up with the charge on our aluminum. Oops. That charge on the aluminum is +3, but we actually could have figured that out just by looking at the fact that it's in group 13 of the periodic table. It ends in 3s2, 3p1. Let's look at a transition metal because transition metals aren't that easy to predict. Transition metals can have more than one possible charge. So let's say, for example, we have cobalt, and it is present in a, let's say, a 3-to-2 ratio with nitride, so CO3N2. And we know that this is going to be cobalt nitride, but since cobalt is a transition metal, a lot of times we're going to have a Roman numeral that goes in between there that gives us the charge of the cobalt. So to figure out the charge in the cobalt, we just have to look at the total number of electrons that were transferred from cobalt to nitrogen in this compound. Each nitrogen, we know from looking at the periodic table, has a -3 charge, gains 3 electrons. So I'm going to put 3 minus up there. There are 2 of them. So each of these 2 has gained 3 electrons. That's a total of 6 electrons that have been transferred from the cobalt to the nitrogen. So that means that these 3 cobalts had to lose a total of 6 electrons, which means that each cobalt atom has given up 2 valence electrons, and of course when we give up electrons we get more positive. So therefore our cobalt has a +2 charge, which if we then put that into the name, it becomes cobalt Roman numeral 2 nitride. So one last example, what if we had PbO2? So lead is a transition metal. We don't know what its charge is just by looking at the periodic table. How many electrons did oxygen gain in this case? Well, we know oxygen always gains 2, so it has a -2 charge. It's in group 16. We also know that there are 2 of them, which means that 4 total electrons changed hands. And since there's only 1 lead atom there to do that, to give up those 4 electrons, that 1 lead atom must have given up all 4 electrons. So it has a +4 charge. So therefore this would be lead 4 oxide.